Hi, I'm Caroline, and if you've ever found the word mole confusing or intimidating, you're not alone. A lot of students find this hard to understand. But this video is here to clear that up once and for all. We'll break down what the mole represents, how it links to particles and atoms, and why chemists are obsessed with that big number, 6.02 times 10 to the 23. So if you're revising for GCSE Chemistry and really want this topic to finally click, hit subscribe and let's dive in together now. Let's start with what exactly is a mole, and we don't mean this little creature here. So a mole in chemistry, the word gets thrown around a lot. Often we get to the point where we can do loads of calculations, but we're not actually sure what is going on at the heart of it. What is a mole? So to put it really simply, it is a word that represents a number. And you know other words like this. So for example, a pear means 2. If I have 2 bananas, I have a pair of bananas. Another word might be dozen, which represents the number 12. So if I have a dozen hot cross buns, I have 12 hot cross buns. The word mole means the number 6.02 times 10 to the 23. And you can see it written in full, that very big number down below. The same thing applies. So if I have 6.02 times 10 to the 23 kittens, I have a mole of kittens. Now that would be a lot of kittens and a lot of chaos, but the point stands. The word mole represents a number. A dozen is 12, a mole is 6.02 times 10 to the 23. Now note for me that sometimes this number is also called the Avogadro's constant. That is the name for that number, a bit like the name for the number 1, 2 is 12. Don't let that confuse you. It just means that number, 6.02 times 10 to the 23. And when I have that number of something, then I have a mole of that thing. So now we know what a mole is. It's a word that represents a number. We're going to start using it. I'm going to talk you through several examples, but what you're going to see is we're going to start with dozens, questions involving the word dozen. Because if we understand what to do when the question is asking about dozens, then we can apply the same logic to moles. And it's a really good exam technique point. If you get confused when you're reading a question, then you go back to, if this word was not mole, it was dozen, what would I do? Would I be timesing by 12 or dividing by 12? And then you can apply the same logic. By the end of these, you're going to be using Avogadro's number super confidently. Make sure that you hit pause if you want to have a go at the question before I actually talk it through all the way to the answer. So if 1 dozen pigeons are 6,624 grams, that means 12 pigeons weigh that amount. I want to find the mass of just 1 pigeon. So I take that 6,624 grams and divide that by 12, divide by the number of pigeons in a dozen, and that gets me to 552 grams. That is the mass of 1 pigeon. This time, 1 mole of carbon-12 atoms is equal to 12 grams. Now remember, a mole represents a number, 6.02 times 10 to the 23. So in order to find the mass of 1 carbon atom, I'm therefore going to take that 12 grams. That 12 grams is all of those carbon atoms added together. And I'm going to divide by the 6.02 times 10 to the 23. Same if I had 1 dozen, I'd be dividing by 12. I have 1 mole, so I'm dividing by the number of atoms in a mole. That gives me 1.99 times 10 to the minus 23 grams. That's a sensible answer. We'd expect the mass of 1 atom to be very small. So here we're now told that 1 biscuit, hopefully a chocolate chip, my favourite, has a mass of 10.24 grams. We're asked to find 2 dozen. Well, first, let's work out 1 dozen. Now, The word dozen represents the number 12. So I'm going to take my 10.24 grams and times that by 12. Then to find 2 dozen, I'm going to times that answer by 2, which gives me 122 grams, 0.88. Now we do need to think about significant figures here, especially if you're an A-level student watching this. Now, my original number in my question was given to 4 significant figures, so that's what I'm going to give here. So therefore, 4 significant figures, there's my first 3. I'm going to round this to 0.9 grams. Don't forget units. There we go. Let's apply the same logic here. We're told that one 63 copper atom has a mass of 1.045 times 10 to the minus 22 grams. First thing that I'm going to do is find out what 1 mole of 63 copper atoms weighs. Now there are 6.02 times 10 to the 23 atoms in a mole. And if you get confused at this point, remember, swap out the word mole for a dozen. If that said 1 dozen, you'd be timesing by 12. So we're going to times by Avogadro's number. Here, I highly recommend putting this in brackets in your calculator. Times 10 to the 23. And that gets us to 62.909. I'm not going to round at this stage because I'm in the middle of a calculation. If I now want to work out 3 moles of these 63 copper atoms, well, I have the mass of 1 mole, so I'm just going to times that number by 3, and that gets us to 188.727. That's not my final answer. I am going to think about significant figures. Now, the original data in the question, which was the mass of the copper atom, is given to 4 significant figures. So that's the answer I'm going to give here to 4 significant figures. So I'm going to keep the 188. There's my first 3 significant figures. 0.7 rounding down from that 2, and that is our final answer. We're told that 1 silver atom, gold is AU, silver is AG, has a mass of 1.808 times by 10 to the minus 22 grams. In order to find out 1 mole, because it's always easier to go to a mole first, I'm going to times by the number of atoms in a mole. Again, calculator brackets is a really good idea here, so you don't get the wrong answer, even though you've got the correct workings. So timesing by the number of atoms in a mole, 6.02 times 10 to the 23, and that gets us to 108.8416. I'm not going to round that because I'm in the middle of a calculation. Now I want to find 0.025 moles of this, and this is 1. So I'm just going to take this answer and times it by the 0.025. That gets us to 2.72 grams. That's our overall answer. Thanks for watching, and if this was helpful, then don't forget to check out the other videos in this playlist and hit subscribe now so I can help you through your GCSE or A-level chemistry.